There appears to be a prevailing, unspoken rule in nature. Life in the oceans is often far more terrifying than life on land. This notion is not only observed today, but can also be traced back through history, even during the age of dinosaurs, which featured aquatic creatures that could instill more fear than renowned land predators like the T-Rex or the Velociraptor. In fact, it's challenging to find an era in Earth's past where survival odds were better in the water than on land. However, there was a brief period long before the dinosaurs appeared when survival was indeed more favorable in the oceans. This time corresponds to the Late Permian, which spanned from about 260 million years ago. It was a time when Earth was nearly unrecognizable, including the nature of time itself. Days were shorter, averaging around 22 hours, due to the Moon's closer orbit. Geographically, the planet was also dramatically different. Most land masses were united in the supercontinent Pangaea, which brought together regions we now know as Africa, the Americas, Antarctica, India, Australia, and parts of Europe. Only to the east could one find relatively larger land masses that were not part of Pangaea, with the largest being a landmass comprising present-day Siberia, Kazakhstan, and northern China. To the south lay another significant landmass made up of South China and parts of Southeast Asia, along with islands like Turkey, Iran, and Tibet, which were surrounded by the Tethys Ocean on one side and the Paleotethys Ocean on the other. Moreover, to the west of Pangaea was Panthalassa, the super-ocean that covered over 60% of Earth's surface and was twice the size of today's Pacific Ocean. Just imagining an ocean that vast is daunting, making it appear almost inhospitable. Surprisingly, though, Panthalassa and its counterparts were relatively calm in terms of the life forms inhabiting them. Sharks had existed for about 200 million years by this time, and if you're familiar with the Permian marine ecosystem, you might envision the Helicoprion, an 8-meter-long shark that became famous for its uniquely unsettling spiral of teeth. However, by the late Permian, the Helicoprion had already gone extinct, leaving the oceans with relatively few large creatures. While there were smaller relatives of this shark still swimming, none matched its size. The largest was only about 2 meters long, with teeth suited for softer prey like squid. Other shark groups, such as the sphenacanthids and hybodonts, were also present, but typically measured no more than 1 meter long. Additionally, the eucrustaceans, an extinct group of arthropods, were present, but their numbers had dwindled significantly since their heyday during the Devonian period. The Capitanian mass extinction event, which occurred about 260 million years ago, had decimated marine life, resulting in a dramatic decline across multiple species. This event was more destructive than both the Cretaceous, Paleogene, and Triassic-Jurassic extinctions, impacting marine ecosystems more severely than terrestrial ones. In contrast, despite life in the waters seeming relatively stagnant during the late Permian, it was a different story on land. The Capitanian extinction had wreaked havoc on terrestrial life, but that environment recovered more quickly. Interestingly, this recovery led to the emergence of new dominants in the ecosystem, as the ancient rulers were removed from the picture. This paved the way for the rise of the Dinocephalians, a group of large-bodied therapsids that thrived throughout much of the early and mid-Permian period. Though they were successful for a time, they too would eventually face their own challenges. Thus, while the late Permian oceans may seem dull at first glance, they actually played a pivotal role in the broader narrative of Earth's history, highlighting the contrast between marine and terrestrial life during this turbulent period. Meet one of the most fearsome predators of the late Permian period, a creature whose fossilized remains suggest that some adults could reach lengths of over 11 feet and weigh more than 1,000 pounds. To put that in perspective, that's roughly the size of a large bear. However, most individuals were more comparable in size to modern tigers. What set this apex predator apart wasn't just its size. It was also built for both power and speed. With exceptionally strong, long limbs, it was surprisingly fast, allowing it to outpace a variety of medium to large herbivores. Once it caught its prey, the outcome was often devastating. This predator boasted elongated post-canines and massive upper canines that measured up to 6 inches long, among the largest teeth seen in non-mammalian therapsids. These teeth weren't just large, they were curved and serrated, perfectly designed to slice through flesh, cause severe blood loss, and inflict catastrophic damage to vital organs. Despite its obvious killing power, paleontologists are still debating exactly how this predator hunted. Some believe it may have used a strategy similar to saber-toothed cats like Smilodon, targeting the neck with precision strikes. Others think it might have relied on a bite-and-retreat tactic, allowing blood loss and shock to weaken its prey over time. Either way, these methods guaranteed a grim fate for any animal it pursued. This formidable predator wasn't confined to a single region. Fossil evidence shows it had a widespread range, inhabiting areas that are now parts of Africa, Asia, and European Russia. It also proved to be highly adaptable, thriving in a variety of environments, from the warm floodplains of South Africa to the cold, arid deserts of Russia. Some experts even speculate that to survive in these colder climates, it might have possessed a form of fur, though this theory remains unconfirmed. But the Late Permian wasn't ruled by just one terrifying predator. The era teemed with other Gorgonopsids, especially in Russia and South Africa. In Russia, smaller species like Proslavlavia and medium-sized predators like Suo gorgon shared the landscape, maintaining Gorgonopsid dominance over many ecosystems. Meanwhile, South Africa was home to a whole subfamily of giant Gorgonopsids known as the Rubidgeinae. While this predator may have been the largest of its kind, the Rubidgeinae were, on average, the most robust group, characterized by strong skulls, continuous tooth replacement, and deeply serrated teeth, likely even more effective at cutting through flesh. One of the most notable members of this group was Rubidgea Atrox, a species found in what is now South Africa and Tanzania. Some individuals grew as long as 10 feet, making them formidable apex predators in their own right. With these giants roaming both hemispheres, the late Permian landscape was anything but safe for herbivores, who faced relentless pressure from these powerful carnivores. In short, the late Permian period was a time of terrifying predators, and this apex predator stood at the top of the food chain. Whether in the frigid deserts of Russia or the scorching plains of South Africa, it reigned supreme, a true testament to nature's ability to craft efficient, adaptable hunters. The predator in question was strikingly impressive, particularly due to its skull, which constituted over 15% of its overall body length. The recovered skulls were notably thick and displayed signs of skull bossing, bony projections that suggest this creature was engineered to bite and grapple with formidable prey. However, interestingly, despite this adaptation, the reconstructed bite force of this predator, estimated at around 715 newtons, was not exceptionally strong. It was only about 20% more powerful than that of a wolf. This indicates that while its design was optimal for piercing through flesh and tough hides, it did not possess a powerful bite relative to its size. Similar to the predator mentioned, the Rubidgea also had a significant ecological impact but was often not solitary. Indirect evidence suggests that it frequently coexisted with other members of its subam, which included 9 genera varying from medium to large in size. The prospect of cohabitation with similar predators raises concerns, as both the Rubidgea and a contemporary species, the Transavia, inhabited the late Permian and southern Africa. Their comparable sizes and builds suggest they likely occupied the same ecological niche, potentially leading to frequent competition. The late Permian era was vividly alive with predators, including numerous other fearsome creatures. Among the most notable were the Theosialians, which emerged during the Middle Permian. Unlike the Gorgonopsids, they did not reach massive sizes at this time, but were in fact more diverse, with species spread across Russia, Antarctica, Africa, and China. While a small number were herbivorous, the majority were predators, easily mistaken for Gorgonopsids due to their large skulls and similar body structures. However, key differences set them apart. Theosialians typically had broader, deeper skulls, smaller, straighter teeth, and more compact physiques. This diversity led to various hunting strategies not seen in Gorgonopsids, and it suggested that some species, like the dog-sized Ichibops and Euchirsia, may have been venomous, the first tetrapods possibly to evolve venom. Some Theosialians displayed semi-aquatic tendencies, such as the Idosuids, while others were strict terrestrial hunters that employed unusual saber teeth, as evidenced by the skylac of swords. The standout predator among the Theosialians was the Moscar Rinus, comparable in size to a jaguar, featuring a lion-sized head equipped with numerous sharp conical teeth. Its disproportionately large head indicated a strong bite, and paleontologists theorize it hunted by pinning its prey with powerful forelimbs, inflicting damage with its razor-sharp teeth and strong jaws. Fossil records indicate that the Moscar Rinus was one of the most abundant Theosialians during the Late Permian and one of the few non-Gorgonopsids to attain apex predator status. Interestingly, while it was certainly successful, larger Theosialians existed, such as the Megawhia, which measured approximately 3 meters long. This relative of the Moscar Rinus roamed European Russia in the first half of the Lingian period and is recognized as the largest known Theosialian. Evidence from coprolites or fossilized feces suggests it likely preyed on large diodon, perhaps employing venom in its attacks. Some studies propose that it had venom glands and ducts capable of delivering lethal amounts into its prey, although this claim remains somewhat controversial within the paleontological community due to the poor condition of prey remains. By now, the Late Permian should appear as a chaotic ecological landscape, bustling with Theosialians and Gorgonopsids. Yet these two groups were not the entirety of the picture. Various other carnivores also populated the environment, each distinct in appearance. Among them were the superficially crocodile-like Protosuids, which were slender but could grow large, equipped with giant needle-like teeth. As reptiles, this group could be either terrestrial or semi-aquatic hunters and were discovered on every continent except Antarctica and North America. Additionally, there were the Cronosukia, which also bore a resemblance to crocodiles, but featured extensive armor along their backs, likely providing protection against attacks from larger therapsids. Members of this group exhibited significant diversity. They could be fully terrestrial or semi-aquatic, showcasing the dynamic and varied ecosystem of the time. The Late Permian period wasn't just a time of terrifying predators, it was also home to a fascinating array of herbivores. One of the most common was Lystrosaurus, a badger to pig-sized dicynodont that thrived during this era. Though it had a somewhat unusual build, Lystrosaurus was not to be underestimated. It had strong forelimbs and tusks that may have been used to dig deep burrows, providing crucial protection from both predators and the harsh environment. Interestingly, the art of burrowing wasn't unique to Lystrosaurus. Other groups, like the Chiomodontoids, also evolved digging techniques, using their broad skulls to shift large amounts of soil. On the opposite end of the spectrum were the Parasaurs, which took a different approach to defense, evolving into heavily armored tanks reminiscent of modern-day ankylosaurs, minus the club tails. Many species in this group had large bony scutes embedded in their skin and dense heavy bones that added extra protection. They were also some of the largest herbivores of the Late Permian, with the most famous member, Scutosaurus, weighing over 1.2 tons and growing to a size comparable to the largest Gorgonopsids. Due to its massive frame, Scutosaurus was a slow mover, relying on its armor and the spiky protrusions on its skull to deter would-be attackers. While this particular genus was only found in what is now European Russia, the Parasaurs as a family had a global distribution. Other herbivorous groups worth mentioning include the Kingoreidae, Bentonix, and Dendriosaurus, each contributing to the dynamic ecosystems of the time. Despite the intense competition on land, the skies of the Late Permian were surprisingly quiet. Unlike the Mesozoic era, which saw giant pterosaurs capable of preying on smaller dinosaurs, the Late Permian didn't have any aerial predators of that scale. The largest flying creatures were the griffinflies and Pileodictyoptera, enormous by insect standards but harmless to larger animals. These creatures were relatively rare, thanks in part to the collapse of carboniferous rainforests which had previously supported a more diverse range of flying insects. The most notable airborne vertebrates were the Weigeltisaurids, a family of gliding reptiles that grew no larger than a modern bat. While having one land in your hair might have been startling, these creatures posed no threat to anything bigger than an insect, spending most of their time in trees and using their specialized limbs to navigate the forest canopies. But if the skies were relatively calm, the land was anything but. The Late Permian world was a harsh place, with life clustered in a few key regions, mainly what is now European Russia and Africa. Vast swathes of the supercontinent were nearly uninhabitable, with average temperatures reaching 35 degrees Celsius, twice as hot as modern Earth. This extreme heat fueled severe aridity, creating massive deserts near the equator where few species could survive. To the north, the central Pangaean mountains stretched across the continent, casting long rain shadows that triggered droughts and made survival even more challenging. If these conditions existed today, life would be thrown into chaos. But shockingly, this was still a mild period compared to what was coming. Around 252 million years ago, the Late Permian period drew to a close with the most catastrophic mass extinction event in Earth's history, the Great Dying. This apocalyptic event is widely believed to have been triggered by the massive volcanic eruptions that formed the Siberian Traps, a vast expanse of volcanic rock roughly the size of Western Europe. These eruptions unleashed unimaginable devastation, with lava flows up to a kilometer thick and a relentless outpouring of carbon dioxide and sulfur that superheated the planet's surface. In some areas, average temperatures may have rivaled those of Death Valley at its hottest. Even if you had some supernatural resistance to heat, survival would still have been grim due to the toxic gases that choked the atmosphere, leading to oxygen levels plummeting and causing hypoxia events across the globe. To make matters worse, some scientists believe these volcanic eruptions severely damaged the ozone layer, potentially increasing ultraviolet radiation by over 5,000% in certain regions. The aftermath was staggering. About 57% of all biological families and 83% of genera went extinct. For comparison, the more famous KT extinction event that wiped out the dinosaurs only eliminated about 17% of biological families. As devastating as the Great Dying was on land, life in the ocean suffered even more, with rising water temperatures and acidification wreaking havoc on marine ecosystems. Interestingly, though, a swim in the ancient seas might have offered some temporary relief. Water temperatures at the time were similar to those of a jacuzzi, making the ocean a strangely inviting refuge compared to the hellish conditions on land. The Late Permian was a period of extremes, from powerful predators to armoured herbivores and apocalyptic climate events, a true testament to nature's ability to both create and destroy. Thanks for watching, and until next time.